Today's lesson is on direct and partial variation. It is part one of the slopes series. If I've got a student working at a stadium and he makes $12 an hour, and then I have another student also working at a stadium, but this student makes $12 a shift. The entire shift he makes $12 plus $2 for every program he or she sells. And so if I want to look at the differences between these two, we can do that together. We can do that by setting up a table of values to see what are the differences between the two. Why is this one different from this one? And what makes them different? So if I look at the first one, we're going to create a table of values. We'll have a time in hours. And for this, we're going to put salary. And so at 0, this person makes no money. So we'll put 0. When he works for 1 hour, he makes $12. Works for 2 hours, 24. 3 hours, 36. And 4 hours is 48. You can see where that's going. For the second one, let's see what's dependent on what. What depends on the salary he makes? He's getting $12 no matter what. That's per shift. But it's $2 for every program he or she sells. So the salary is dependent in this case, not on time, but number of programs. And then we've got salary. And in this situation, when he sells no programs, he's still making $12. Once he's sold 1 program, he is now making $14. Once he's sold 2 programs, he is making $16. 3 programs, we add another, and 4 programs, we add another 2. There we go. And so there's a difference here. This one depends on the time, and it starts at 0 because if he doesn't work, he's not getting anything. This one here depends on the number of programs. He's getting $12 for basically doing his shift, and then $2 for every program. We can look at the differences here, and when we look at this, the difference between these two is 12. The difference here is 12. The difference here is 12. Now, what about this here? What are the differences here? The differences here is 2. Differences here, 2. The difference between these two is also 2, and etc. Okay, and we'll get back to why that is important. So if I were to graph these two, they would look different, wouldn't they? Let's take a graph and see how this would be different, one from the other. So if I have my grid here, and I were going to put salary and time. At 0, we have 0. At 1, we're making $12. At 2, we're making $24, etc. And my line will go up something like that. Okay? All right. Now, if I want to use a similar grid, right, and I was going to put the other one on this over here. Now, this time, this is salary again, but here we have number of programs. And what we had for this one, what's a bit different At 0, he made $12, right? When he sold one program, and so I'm going to make a little line indicating that I'm jumping some numbers, and then I'm going to go by 2s, like this. And over here, I'm going to put a number of programs. And so when he did not sell anything, he still gets, he or she gets $12. We're starting here now. After selling one program, 14, 16, 18, etc. And our line goes like that. Now the differences here, what are the differences? Well, this one here, we are starting at the origin at 0. This one here, we're starting over here. If we were going to create an equation for these, we would say that based on our information, the salary, which is our y, and this is our x, we can say in order to figure out y, we are multiplying every x value by 12. Okay? And we can do that. We can figure out how many hours he works. Based on that, we multiply by 12 and we get our answer. For this one here, what are we going up by every time? It looks like we're going up by 2. So we have to multiply all the x values that we have. We're multiplying them by 2. But what else do we have? Well, are we starting at 0 like we did here? No, we're not. We're starting at 12. So we need to add 12. Let's check our work. If I put 1 into here, I get 2 times 1 plus 12 is 14, and this works out. The differences between these two is that one starts at the origin here, and this one starts further up. And so the difference is this is called direct variation because it is going up directly by the number 12. You multiply the x values by 12 to get your y values. In this case, it is partial because partial variation because yes, we are multiplying every value of x by 2, but we are starting with 12. So we have this extra little number here. This number here is 0. We don't put it. We don't need to put plus 0, but that's what it is. So I'm not going to put it because I really don't need to do that. And that's the difference between direct and partial variation. The point here where it starts, okay, is called a y-intercept when the value of x equals 0. It is also called the initial point where we are starting our information. It can also be called the fixed value. So we can say that the fixed value for doing this work is $12. And then it all depends on how many programs you sell. And so the y-intercept is when the x value is 0. The initial point, the fixed value. These are all mean the same thing. And this is the difference between direct variation and partial variation. We can write it out so that we have two equations, and these two equations are very simple. Direct variation, y is equal to mx. This here is the constant of variation. It's the number that you multiply the x by. And this is partial variation. Y is equal to mx plus b. Again, this is the constant of variation. And this is the y-intercept. initial point or fixed point. And now you have any equation of a line is either going to be a direct variation or a partial variation. And they can be organized in this fashion, where here you start with 0 because there is no y-intercept, and here you start with a y-intercept.